So we had two, like I said before, we had two terms there and there. Okay, so really we're finding the derivative of both. Okay, so the derivative of the first term, 8x, minus the derivative of the second term. The derivative of the second term is a log. So the rule for a natural log is right here. Derivative of the inside stuff over whatever it was to begin with. Okay. Okay, so here we go. Let's see. So we have 4x over 2x squared minus 1. Okay, that's the derivative there. That's the derivative there. But that's where we stopped last week. Now today they want us to find the equation of the tangent line at a certain point. Okay, so once I find the derivative, what do I got to do now? Find the slope, right? Slope at 1, 4. Okay, at that point. So I plug in 1. Everywhere there is an x. Plug in 1. Plug in 1. Plug in 1. And what do I get? Which is 4. There you go. Okay. That's the slope. So we got y minus equals the slope, x minus equals. So what do we do now? Enter into an equation. Yep. So we have a point here, right? We got a point 1, 4. 1 is x. 4 is y. We don't have to do any more work because they gave us x and y. Sometimes they just give us x. Sometimes they give us both. Okay. All right. So you'll have those types of problems too. These types, any type where they say find the equation of the tangent line, more likely they could still be multiple choice, but they could also be free response. Like if they just ask you to find the derivative, like this one here, if they just ask you to find the derivative, that's usually a multiple choice question. If they ask you to find the equation of the tangent line or find the slope of the tangent line, it could still be a multiple choice, but it could also be an FRQ. Okay, so those are more FRQ types, which we had one, which we had, which you guys have had quizzes on, right? In your quiz, questions like that, quizzes were free response. Okay. Okay, so for today. So that set of notes that I gave you today is the last set of notes for this chapter. Okay, so let me upload mine and then we will take a look at it. I can find it, there we go. So the last thing in this chapter is derivatives of inverse functions. So the first page, while I'm loading this up, read the first page, because the first page will tell you what an inverse is. So if you have no idea what an inverse is, read the first top left box, top left. Those are all things about the inverse, what an inverse is, what it does, all that stuff. Okay. Okay, so what is an inverse? What is an inverse? Does anyone know what inverses are? Or just the word inverse? What does the word inverse mean? Flip, yeah. Yeah, exactly. You guys have seen inverse, the word inverse, many times. Back in math 1, you guys saw equations that look like this. 2x plus 8 equals -12, solved by using the inverse operations. What does that mean? I know how to solve, but what does inverse operations mean? No one knows how to do that? You guys should all know how to do that. That's easy stuff. What did that mean? Solve using the inverse operations. Well, what's an operation? In this class, what is an operation? What's an operation in this class? That one's too easy for me to tell you the answer, so I'm not going to tell you the answer. I can sit quietly too. Even easier than that. Even easier than that. Yeah, you guys are probably up here. What's an operation? Give me an example of an operation. Even easier than that. You're over. Yeah, thank you for participating. But Sebastian, but you're way, yeah, but I think that's the problem. You guys are up here. I'm looking for down here. Getting closer. What's an operation? Operation. Operation. Math. There you go. We have 4 of them, right? They're called addition, where we put things together. They're called subtraction, where we take things apart. Division, where I find out how many groups can fit inside of one. And then multiplication, where you're multiplying, right, by groups. Those are the operations. So now let's go back to my question. If I said solve that using inverse operations, what does that mean? There you go, right? What would be the first step over there? There you go. It says +8, right? If it says +8, the opposite of +8 is subtract 8, right? And then we go from there, right? So what do I mean by inverse then? When I use inverse over there, what am I talking about? Yeah, so why do we call those inverse operations? What you just did, that step you just did, why do we call that inverse operations? Roman? You're reversing the operation, right? You're really saying, okay, instead of adding 8, I'm going to subtract 8, right? Instead of adding 8 steps, I'm going to take away 8 steps. Just the inverse, right? That's all inverses are, right? Look at the first one, right? X's and Y's are swapped. Isn't that what we did over here? Instead of a +8, we subtracted 8, right? It's the same thing, okay? So what inverses are when we switch places with X and Y, okay? So the domains and ranges are swapped, right? The graphs, if I were to graph them, they're symmetric over Y equals X. The graph Y equals X is it's a diagonal line that looks like that with a slope of 1. Okay, so they're all, so if I graphed a function and its inverse, it would reflect over that line. So that means if the original had a point right there, its inverse would have a point right there because it's reflected. Okay. The next one, if G, F, and G are inverses of each other. So if we know something are inverses of each other, this is true. We won't necessarily use this one in that class, but it's true. For f to have an inverse, it must be 1-to-1. So it must pass what's called the horizontal line test. You guys have heard the vertical line test, right? What's the vertical line test? Vertical means this way, right? So what is vertical line test? Like, let's say this red graph, the red line that I just drew. Would that pass the vertical line test? It would. How do we know that? Exactly, right? I use a pencil, or since it's bigger, I can use a ruler, whatever you want. And then if my ruler hits multiple points of the red line at the same time, it fails. But this one only hits it at one time, right? The red is only hitting the ruler at one time, right? So it passes the vertical line test. You guys did that in Math 1. This one is a horizontal line test. So it's just like this. You have a horizontal line and it does the same thing. Does it pass at the same thing? No, it also passes the horizontal. So this guy right here would have a inverse. That guy would have an inverse. Okay, can anyone think of something, a type of function that wouldn't have an inverse? Quadratic, yeah, watch. Quadratic looks like this, right? A parabola, right? So if I go from left to right, it's close, but it only touches red at one time, right? So it passes the vertical line test. But when I flip it and do the horizontal, it fails pretty badly. Everywhere it hits twice. It hits twice. Everywhere it hits twice, right? So quadratics don't have inverses for that reason, okay? Quadratics do not have inverses. That's what that means. Monotonic, always increasing or decreasing. Functions always have inverses. So in order for something to have an inverse, it always has to be increasing or decreasing. It can't change. This one decreases, right? We always come from the left. So it decreases and then increases. It changes, right? So it's not monotonic. Okay. Monotonic means it always is decreasing or always is increasing. That line I had before. That guy's always increasing, right? From left to right, it's always increasing. Down here to up there, so that's monotonic, okay? The inverse function is denoted by f to the -1 of x, and it undoes the work of the function. That's why it's called an inverse. Done. So if you see that little -1, that means it's an inverse, okay? So the first couple, I wanted to just go over what an inverse, how to find an inverse, okay? The steps to find an inverse aren't that bad. The steps to find them aren't that bad at all. We want to find the inverse of this line here. First thing what I would need to do is swap x and y. Everywhere there was an x, needs to be a y. Everywhere there was a y, there needs to be an x, okay? So first thing I would do is change this to y. Y equals, right? Because it's the same thing as f of x. Step 1, swap. So now I have x equals 6y plus 2. That's step 1. Step 2 says solve for x. The way solve for y, sorry. The way you've been doing it for years and years and years, okay? So what's my first step gonna be if I'm solving for y? Subtract 2 from both sides, good. So we got x minus 2 equals 6y. Almost there. Well, how do I get y by itself? Divide both sides by 6, good. So I get y equals x minus 2 over 6. And since it's all divided by 6, you can have like this too. I should have changed that. it would be 2 over 6, right? Because they're both divided by 6, x and -2. But then this guy right here, 2, 6 makes 1/3. Either one is okay. So this is the inverse. Now look at the inverse and look at the original. The inverse is here. And this is the original. What do you notice about them? Yeah. So yeah, so that's 6 up there. What operation was that doing at the top? Multiplication. What operation is it doing for the inverse? Inverse operations, right? What else? Yeah, it's doing the opposite, right? That's what an inverse does. It undoes everything. It was multiplying by 6 plus 2. Now it's dividing by 6 minus 2. It undoes everything. That's what it does, okay? So I want you guys to try this one. Give me the inverse. What is the inverse function of this guy going to be? So the original has a square root, a minus inside, and a plus. So that means my answer better not have a square root. What's the opposite of square root? Say it again. Yeah, what power is the opposite of square root? Squared, right? So it better have a squared in the answer. And then it had a subtraction there. It better have a +5 now and a -3 then. Okay, so let's see. Let's do the steps. That's how I know it'll be the right answer. So let me change this to y equals square root of x minus 5 plus 3. Okay, swap them. X equals square root of y minus 5 plus 3. Solve for x. Subtract 3 from both sides. Okay. And the only way to undo a root, square root, is by squaring. So I square both sides like that. So if I square a square root, that takes away the square root. This side now has a squared. I need to add 5 to both sides. I get y equals x minus 3. Okay. There is the not the derivative, the inverse. So I look at the inverse, I look at the original, and I look at my answer there. Does have a squared. It does have a -3 and it does have a +5. Happy. Okay, it's undid everything. Okay, so that's an inverse. You guys did that in math 3. That was just a little review because I wanted to know what our inverse is, all that stuff. Here's the thing here. So now we're going to take derivatives of this guy here and this guy here. Okay, so aren't these just equations? Yeah, they're just regular equations, right? They're not anything special. They're regular equations. They just happen to be inverses. So don't make it out to be something that's not, don't make it out to be this big monster that it's not. It's not. You guys have found the derivative of this tons of times. It just happens to be an inverse function as well. That's it, okay? And I give you the steps here that make it pretty simple to follow, okay? So here we go. Now this over here is the formal in what you have in your textbook. A lot of it should make sense to you because this means inverse, right? Anytime you see a little tick mark, that means derivative. So you see one here, you see tick marks here, you see them here. So anytime you see that, that means an inverse, right? And you know how to find inverses because we just did one, we did two, all right? And you know how to find derivatives. That's what we've been doing for the last 3 weeks, okay? So we're just kind of putting them together. Even easier than that. So it says, if you want to find the derivative of an inverse function, it's 1 over the derivative of the inverse function. That's all it says, right? So you can find the inverse and then take its derivative. That's one way to do it. I kind of made it a little simpler here. Here's some steps right here. Okay, these work as well. So if you have if one function is the derivative of the other function, or sorry, the inverse of the other function, and they always want you to find the derivative of that guy at a value. They always ask you that. First thing you're going to do is you're going to set f of x equal to that value and solve for x. That's the first thing you're going to do. The second thing you're going to do is you're going to find the derivative of this guy here. We know how to do that. And then you're going to find the answer of f prime to whatever answer you got here. And then the last step is to reciprocal, flip it. You're done. Okay. So let's look at the first one. To it. The original, it says, the original equation is x cubed plus 4x plus 2. That's the original f of x. They want us to find the derivative of its inverse at -3. The slope at -3 of its inverse, not of this guy here, of its inverse. Well, we could just do we could solve the inverse, right? Switch x and y's and do it that way, right? We could do that. That works. But I want to show you how this other way works as well. Okay. So what do the directions say? What's the first thing it says for those directions to your left? What's the first step? Got to give me some help here. What does it say? What's the first thing I got to do with this guy? In context. Don't tell me the directions I wrote. Tell me what I'm going to do here. What's the directions I'm going to do here? In context to this problem here. So it says plug in -3 to the original, to the derivative. So I'm not going to plug it in. You're close. I'm not going to plug it in because if I was going to plug it in, they would have put f of a here. So instead of plugging it in, you're close though. What am I going to do? Yeah, don't it? It's going to be for y. We're going to set it equal to that. Yeah. So we're going to have our equation set equal to -3. Okay. So let's do that. X cubed okay. What do I do here next? Okay, so I did that. Then what do I do? Don't look at me, it's on your paper. My face doesn't have the answers. What do I do with that? Yes. Solve for x. Okay, so I can do that. So solve for x. So that means I got to set it equal to 0. So I add 3 to both sides. Okay. How do I solve for x here? See, that's what I was thinking too. Factor, right? Factor using one of the steps or quadratic formula, something like that. There's a problem here. What's the problem though with that idea? When I initially, that's what I thought too. But what's the problem with that? It's a cubic, right? It's a cubic. So I can't use those rules to do it. I don't think. Let's try. Because factoring says, all right, so multiply A times C. So it would be 5 and 4. Are there any numbers that would add up to be 5 and, or sorry, multiply to be 5 and add up to 4? 5 and 1, no, that's 6. That doesn't work either. So even if we could factor, it doesn't work, right? And we can't use, in math 3, when we said we couldn't do this, we use quadratic formula. And we can't use quadratic formula because it's not quadratic, it's cubic, right? It's not a quadratic. Quadratic means the highest power is 2, okay? So what other options? There's a couple options we could do. What's one of them? There's an easy one and there's a easier one. You just got to know what solve means. What do I mean by when I say solve? Solve an equation. A lot of people don't know what that means. They can solve equations, great, but they don't know what that means. What does it mean to solve an equation? We can't do that because it's solving. It's all one function. Yeah, I can't separate them like I do with derivatives. So I can't separate them and solve them like that. I could if it was multiplication. Yeah, absolutely. If this was multiplication and that was multiplication instead of addition, I could do that. That'd be a great idea. But I can't do that. So again, what does it mean to solve an equation? You've been solving equations since you guys are in 7th grade. What does it mean to solve? Solve for x, right? So what does that mean? Get rid of the x, not get rid of. Say it again. And how do I know that will be a solution? That's one way, right? That's one way. That's an easy way to do it. That's what I was thinking, the easy way. Solving an equation means plugging in a number here. And if I plug in the number and do everything here, it should equal what it equals here, right? That's solving. That's what you do, right? That's an easy way of doing it. This is not that bad. This one's not that bad, right? So what number could I plug in for x that would give me 0 as an answer? -1? Did you get what, -1? Will -1 work? So if I plug in -1, -1 cubed, let's see, -1 cubed plus 4 times -1 plus 5. So I get -1 here, minus 4 plus 5. That works. Yeah, -1. The answer is -1. X equals -1. That works. Now let's say it wasn't that, you guys are able to do that in your head, which is great. But let's say we couldn't do it in our head. How would we solve it? Because there's going to be problems like this. How do we do it? So the way we do it, I'll tell you how to do it, but I'm not going to tell you. Here's the thing. We don't use these a lot in this class, right? We haven't too much. I think we did a good day or two with them. This would be if it wasn't so easy to do it like that, you guys did it in your head, it would have to be a calculator question. Okay, so I'll give you a calculator. How do you solve this using a calculator? Does anyone know? It's paperweight then, because it doesn't really help us, right? It's how do I solve it using a calculator? Using a graphing calculator. It's one of the things you need to be able to do in the calculator in this class. There's only about 5 things you need to be able to do with a calculator in this class. One of them is solving. How do I solve? How would I do that using the calculator? Because students are always asking, can we use calculus? Can we use calculus? Sure. Do that one at the calculator. Well, I don't know how to do that. Then what do you use as a calculator, right? How would I do it? So where are the zeros on a graph? Yeah. So let's say I have that one. This is not the same graph, but I just have this graph in front. So how do I solve? Where would I look? So you, Raj, where would the solution be on this question, on this answer here? Because that's where it crosses the x-axis. That's what I would look for. So what I would do using a calculator, we've actually done this in class before, is put this guy in there. Put x cubed plus 4x plus 5 into the calculator. Graph it. Find out where it crosses the x-axis. Okay, find out where it crosses the x-axis. It's only going to cross at one spot. Guess where it's going to cross? -1. -1. Okay, so that's one of the things you got to be able to use the calculator for. Okay, so if you don't remember, I did a video on that when I recorded the video when we actually used calculators, because I said that's one of the things you're going to need to know how to do. Okay, so getting back to this. Step number one done. So what do I do next? What's step number 2? Oh, step number 2 that says to the left. Of f of x. Okay, it's pretty simple. Derivative of f of x would be 3x squared plus 4. Check, did that. What does step 3 say? Step 3 says find f prime from your answer for step 1. Okay. So step 3 says f prime. What did I get from step 1? -1. So this notation means find the derivative and plug in -1. I already found the derivative, it's right here. So all I got to do is plug in -1. Okay, so -1 squared is 1. 3 plus 4 equals 7. What does the last step say? Flip it. So if I flip 7, what would I get? 1/7. Done. Okay. So here's the thing. We're going to do one more problem and then we'll be done. But first, here's the thing about these inverse function derivative problems. I'll be honest with you guys. If you look at any AP test, and there's 50 something questions on it, you'll find maybe one of these on there. Maybe one. I've seen some tests where there's 0. So they're not big in terms of the actual AP test, but I mean, one question could be a lot, right? On the next test, there's only going to be 8 questions on the multiple choice, right? 8 questions about. I mean, that's a difference. That could be a difference between an A and a B, right? So in the grand scheme of things, they're not that important. But for our test, if you want an A instead of a B, they are important, right? Because one test, 1 out of 8, because you'll probably have one of these on the test. When we take the test, you'll have one of these, okay? So on this test, 1 out of 8, that's over 10%, right? So that could be the difference between an A and a B, depending on how you do on the free response. So you want to be able to know how to do these. But in the grand scheme of things, in terms of when we start reviewing in March and April for the test, we're not going to really hit these too hard because it's maybe 1 question out of 50 that you're going to see on the AP test. So it's kind of like, it's important now, but in the grand scheme of things, it's one of the things that kind of we don't really focus on when we review. Okay. But like I said, for right now, I'm telling you right now, you're gonna have 1 question on the test, and it's gonna be like this. And if you look at it and you have no idea what you're doing, it could be the difference between an A and a B. So it's important to know now. Okay. Okay, so here we go. Last one we're gonna do. This guy right here. And then we'll pick up tomorrow, but let's do this guy, letter B. Okay. All right, so f of x is our function. It says g of x is the inverse of this guy. G of x is the inverse of this guy. Find the derivative of g at 1. So really what we're doing is we're finding the derivative of the inverse and plugging in 1. Okay. So that means we use our steps. Step 1, what do I do step 1? What did step 1 say to do it again? There you go. Set 1 equal to the equation. So we got square root x cubed minus 7 equals 1. That's what the equation said. That's what step 1 said. What do I do with that now? What do I do with that? So I set it equal to 1. What do I do now? What do I got to do with that? Leave it there? Solve it, right? I got to solve it. I got to solve it. Okay, so I could set it equal to 0. You could do that. All right. We could do it like this. Good. Oops, not plus 7, minus 7. Minus 1 on the outside. Tell me, there we go. There we go. And then what do I do? How do I solve for x? Say one. What's up? The 1 I have to subtract. Say it loud. I can. Yeah, that's what I need to do, right? I need to get rid of the square root. That's the first thing I need to do. So how do I get rid of the square root? Square it. Okay, let's do that. I can do that. Okay, so I square it. So can I just do this? Nope, not if you want to get the right answer. Why is that wrong? Yeah, I need to include the 1, right? I need to include this guy here, and I need to do it to both sides because it's an equation, equal. I got to do it equal to both sides, right? What's the problem here, though? It's not wrong. That's nothing wrong. There is nothing wrong with what I did. But what's going to be an issue on my next step? What's this going to be? What's the if I square this side, what is it going to be? No. So a lot of people say, oh, square this guy and then square this guy and you got your answer. That doesn't work it that way. It's kind of like this. Does this equal x squared plus 1? It doesn't, right? It's a binomial, right? So I would have to do FOIL or some sort of binomial times a binomial, right? I would have to do first, outer, inner, last. I would have to do all of that, and I don't want to do that, right? So let's go back here. How could I avoid that? Some of you guys looking at the clock, tick tock. Yes. I think I know what you're saying. Yeah. So yeah, so what we're gonna do, I think this is what you're saying, I'm not sure, but this is what we're gonna do. We're gonna start over because we made the problem a little too hard. What if I squared it right now? Is that what you're saying? Would that alleviate that mess? Help me out here. If we want to do the problem, we got 3 more steps. We got to finish today. The only thing in here is the square root. So I just square root. There's no -1 now. And then the square of this side is 1. Now I would subtract 1 from both sides. Now you can do that. X cubed minus 8 equals 0. How do I solve for x now? Still haven't solved for x. Step 1, still not done. How do I solve for x? Yep. You can do this in your head, or isn't there just 1 x here? Before there was 2 x's, so I couldn't get x by itself, right? But here there's only 1 x. So I just get x by itself. What times itself 3 times make 8? 2. X equals 2. Step 1. Done. Step 2. Yep, if you guys want to pack up, please tell me. Okay, let's find the derivative of f of x. So the derivative f of x okay. So I got to change that. How do I find the derivative of that guy? Change the power, good. And then what am I going to use? Chain rule, good. Chain rule. So I move x, so I move 1/2 to the front. X cubed minus 7. Take away power times what? 3x squared. Okay, that's the derivative. Step 3. Okay, let's do that. Plug in 2, 1/2, 2 cubed minus 7 to the negative 1/2 times 3 to the second squared. Okay. So what do we get? As soon as you tell me, we can back up.